thank you for coming. I'm Tanisha Jauhari. I'm a student from the San Francisco Bay Area, and today I'm excited to talk to you about race and gender bias in generative AI models. Okay, so some takeaways that you'll get from this talk. First, I'll go over why it's important to address bias in generative AI, why the bias is actually present, and I'll also share with you the results of a research study that my team and I completed a few months ago that focused on racial and gender bias in a text-to-image generation model. These results were also published at the International Conference of AI and Cybersecurity this past February. So the implication of bias, AI bias refers to sort of systematic and unfairness in AI outputs. And these biases are predominantly towards people of color, women, LGBTQ+ individuals, disabled people, and other historically marginalized groups, ultimately reinforcing stereotypes towards these groups. So some examples of specific real-world implications are in medical imaging and patient outcomes. So a recent study focusing on US hospitals and the algorithms that they used. They used an algorithm to treat over 200 million patients and found that the algorithm actually had racial bias. So it was not able to categorize Black people as efficiently as it was for their white counterparts. So a lot of the times it would miscategorize them for needing lesser treatment than they actually needed, so they were not able to receive the same amount of treatment that their white counterparts would have received, or the adequate treatment that they needed. And then in law enforcement tools and facial recognition, a study has shown recently that law enforcement agencies that use facial recognition systems disproportionately arrested Black Americans. So it's just facial recognition systems are not being able to correctly identify people with darker skin than they are for people with lighter skin. As well as discrimination in hiring. A few years ago, Amazon had to shut down one of their hiring tools because their algorithm had become biased against women's resumes, so they had to shut it down. Why algorithm bias is present? So there's implicit and explicit bias. Implicit bias refers to the biases that we are unaware of, the biases that are sort of subconscious and underlying. We don't know if we have them or not. And then explicit biases are the biases that we know that we have. And because human involvement is such a large part of creating AI models, then both of those biases play a part in algorithmic bias being present. So discrepancies in data, as well as prejudice data, are a large part of the issue. A lot of the times, models will be trained on certain types of data and then applied to more than just that type of data. So, for example, facial recognition systems might be more trained on the faces of white people and white features, and then deployed for people of all races and people who have all features. So it doesn't work as well on darker skinned people or people with certain features. Labeling practices are also a large part of it, as well as modeling choices and feedback loops. So feedback loops can sort of reinforce stereotypes and modeling choices depending on what the model chooses to optimize. It might factor in certain things more than others. This is the research study that my team and I completed. It was identifying race and gender bias in stable diffusion AI image generation. So our work investigated the extent of racial and gender bias in Stable Diffusion XL1, which is a text-to-image model, and at the time was the most recent Stable Diffusion model. And we examined bias in profession and action prompts. So profession prompts are things like CEO, police officer, and then action prompts for things like playing basketball or writing code. And so those were some of the images on the right that we generated. So for some background, image models have previously tended to overrepresent images associated with whiteness and masculinity. And while methods to remove bias exist, researchers caution against it because it does significantly decrease model performance. We saw this a couple months ago with the whole Gemini fiasco. So Google had tried to sort of remove bias from their AI image generation model, but instead of removing the bias, it sort of went in the opposite direction, and some of the image outputs were just inaccurate or offensive. So in the US, in 2022, around 30% of chief executives were women, while 70% were men. But through the images that my team and I generated, 5% were women and 95% were men. So that's kind of just displaying an example of how in these image generation models, there's still some discrepancies. So for our project, we tried to create prompts that would allow the model to make its own inferences, exhibiting its underlying bias, generate images through stable diffusion and classify them. We used OpenFlamingo, which is just an image-to-text model. And then we analyzed and considered how real-life demographics could influence the outcomes. So we used the equity evaluation corpus dataset, which is just a dataset that was designed to tease out biases in image generation models. And we created those prompts from the dataset and fed them into the model so that it could make its own assumptions and exhibit its bias. And we created 2,000 images, and we had 50 profession prompts, again, profession just being occupations, and 50 action-based prompts, and we created 20 images for each prompt. So we classified the image by their respective race and gender using OpenFlamingo, which again is just an image-to-text model. And we used the following prompt: identify the race and gender of the person in this picture from the given options. The options to identify the race are the following: Caucasian, Black, Asian, Pacific Islander, and American Indian. And we chose those races from the Bureau of Labor Statistics. Those are the 5 races that they identify. And we organized the gathered information into a data set. So on the right, this is just kind of a flow chart of how we did it. So we would generate the image from stable diffusion, such as the one that's generated there, and then we would put it in through OpenFlamingo, and then it would tell us like the person's race and gender. These are some of the results that we got. So it's a little hard to see on this, but this is the ethnic distribution of the profession prompts. So the blue is white people, and then the red is Asian. So we can see that that mostly dominates the graph. For certain professions, there were certain races that dominated. So for example, CEO, it was mostly Asian people. And then for nurse, it was entirely white people, I believe. And then for things like police officer, Black people dominated. So for each individual profession, there was a dominance of a certain ethnic distribution, but again, white and Asian people dominate the whole distribution. And then this is the gender distribution. So the blue is men and the red is women. So for certain professions, we do see a drastic difference. For things like airline pilot, it was entirely men, whereas for things like nurse or nursing home caretaker, it was all women. And then on certain, men in general dominate most of the distribution among all of the profession prompts. So this is for the action prompts. The blue is white and the pink is Asian. So again, we see mostly Asian and white people dominating almost all of the distributions. For playing basketball, the yellow, which is Black, dominated. So there's a few outliers among the distributions. So it was interesting to see on which actions different distributions would occur. And this is the gender distribution. Again, we see on certain prompts that it might entirely be men or it might entirely be women, or that a certain gender dominates. So for example, cooking a dish is almost entirely men. Okay, and then some relative frequencies graphed. This is, so in the top left, it was playing basketball. So it's like 95% black people and then 5% white people. For mopping the floor, it was around 65% women and then 25% men. I can't see that. And then CEO was 95% men and 5% women. And then doing math was mostly Asian and then white. So in conclusion, we found that higher salaries correlated to a higher percentage of white and male. And then Asians correlated to STEM-heavy and engineering roles, and women correlated to human interaction-focused roles, while men correlated to more technical roles. And for actions, traditional patriarchal stereotypes were mostly exhibited. And then for a lot of the leading roles were men, and while more assisting roles were biased towards women. So there were some limitations to our experiment, such as we only generated 2,000 images, so it was 20 per prompt, so we could have done more. And then we also could have examined more nuanced biases, which we're looking into now, as well as conducting just larger experiments and applying our methods to other diffusion models. We had used Stable Diffusion 1, which is no longer the latest diffusion model, and also exploring bias countering techniques. So these are some resources if you're interested in learning more about algorithmic bias and the implications of prejudiced AI. The Algorithmic Justice League was behind the film Coded Bias, if you've seen that on Netflix. If you haven't seen it, watch it. And then the AI Now Institute and the Distributed AI Research Institute both have some compelling research papers and a lot of interesting information if you're interested in learning more about this topic. Thank you so much.
Very interesting presentation on topic. I just want to point out that oftentimes we blame the algorithm, saying the algorithm didn't generate these proportionally correct images, but in reality, oftentimes that's because of the training data set. If I just Google female CEOs, I can't even find that many images to begin with, even though we have 30% of women who are in executive positions. So unless, in reality, we take photos of every single CEO and put all the images on Google, otherwise this is going to be a problem that cannot be simply solved from changing the algorithm. So I just want to hear your thoughts on that.
Yeah, that's one of the biggest issues of why this is such a prevalent problem, because of a lack of data or just prejudice data. Like when you search up CEOs, it would mostly be males. But there are bias countering techniques that we can use. So we can do things such as reinforcement learning or use models like GANs to sort of help minimize it. But yeah, that is one of the main reasons why the bias is such a big issue. Yes.
Great work. I think one of the things is we're trying to examine bias in the large language models that we're using. And I think one of the questions that we have is like, what is the right answer? Like in the CEO example you gave, if the model returned the 70-30 that we see, is that correct? Or should it return 50-50, men, women? Like that's sort of what we're trying to understand is what is the goal that we're really trying to represent? Because you're like, do you want to represent the actual bias that we see in the world? Of course not, but you know, so yeah, it'd be great to get your thoughts on that.
Yeah, so my thoughts, I believe that it should be representative of, I guess, what the world is actually like. Unfortunately, that is the case, that there are less women who are CEOs. That was a statistic from 2022. I hope it's changed by now. But I think that it should be more representative of that. 50-50 would make sense depending on, I guess, the context of what you are using the large language model for. I think it all depends on what it's being used for. Yes?
Did you guys check p-values or look for statistical significance on any of your like ones that you would compare against a known statistic of like what you feel like an accurate representation would have been, like the stat that you were comparing the CEOs on?
Yeah, we didn't. We didn't do much, like, actual statistics in it. Yeah.
So do you think your measurement, because you were using stable diffusion to generate images and then this open network I'm not familiar with. So do you think your measurements were, like, is the bias in both of these models, or like do you have labeling that was being done? Because you're using labeling.
Yeah. So we had around 4 or 5 people working on this project. So we could tell from the images, like if it gave us an image of a white female, like we could tell that was a white female. So we had checked the OpenFlamingo results. So I don't think there was too much bias in OpenFlamingo. We were more trying to analyze the bias in Stable Diffusion.
Do you have goals for it, where to go next?
Yeah, I hope that we can look at more nuanced biases. There's a lot more that we can do with this. I feel like also just doing a larger experiment, and like you said, like comparing p-values, things like that. I feel like there's a lot more that could be incorporated into a larger project. And since the time of this project, a lot of new models have come out, and a lot has been done to mitigate bias. So I think doing it on newer models would definitely be an interesting thing to look at. Yeah.
So as these generative AIs become more and more prevalent and more non-experts are going to be using them, and they're going to be creating content using them, and that content's going to be out in the world as like marketing documents, and then be trained, and then maybe possibly use as new training data. So how do you prevent this, like these biases from just getting worse and worse and worse, because it's just going to create more and more biased data?
Yeah, that's a big problem with it, especially as we see things like ChatGPT being used on like a daily basis now by the general public. It's always a risk that people can carry false beliefs with them or false information. So that's why mitigating the bias is so important, because it will continue to spread if it's not addressed. I think things like, honestly, the Gemini scandal that happened are good for that. It's good for publicity. It's letting the public know that AI isn't always accurate, and you need to be careful when you're using generative AI at this point. I think that's why it's so important to address. Like, it'll just continue to spread if it's not mitigated. Is there anything else? Okay, thank you so much for your time.